Oh, we're filming? Yo, Jerry didn't tell me. Okay, so in today's video, we're gonna go over the immune system. Wow, so interesting. And this, apparently, Jerry made this pre-college foundations. It's a pretty bold statement from here, I'm not gonna lie. Okay, so let's see. So we're gonna learn about innate and adaptive immunity, inflammatory responses, and the chemical signaling, identify the role of MHC proteins, humoral and cell-mediated, and immunological memory kinetics. And we just really want to answer, how does the body distinguish between self and non-self to selectively neutralize pathogens without sparring host tissues. Okay, so I think this video would be good for pre-meds. Uh, pre-meds, yeah. I don't know. I don't think I can do pre-med. I don't know. I just can't be. It's a long time. I'm not gonna lie, but it's okay. Okay. Let's keep going. Okay, so we have we have a lot of defenses when it comes to immune responses, and our first line is physical and chemical barriers, which is like your skin, the mucous membrane, stomach acid, and lysosomes and tears, and this is always active. And our second line of defense is our innate immunity, which is phagocytes and natural killers and antimicrobial proteins. And these are rapid, non-specific internal defenses. And our third line is adaptive immunity, and this is where there are targeted, highly specific responses involving B and T cells. And this is where we have help T cells and memory cells and clone. Yeah. Oh, okay. Next we have innate. Okay, we have innate versus adaptive summary. We have a pretty good uh a figure here if you want to pause, if you want to look at it. But our innate response is evolutionary, and it works against all broad classes of pathogens, and there's no memory stored for this one. But our adaptive ones are unique antigens, and it takes days to develop, but builds long-term protection, and that's where memory comes to play. And both systems communicate via cytokines, which are signaling proteins. Next, we have our innate second line, where we have phagocytes, which are cells like neutrophils and macrophages that entirely engulf and digest pathogens, and they act as like the first responders. And we also have natural killer cells, and these identify and destroy virus infected or cancerous host cells by inducing apoptosis. Sorry if I say it wrong, but which is programmed cell death. So phagocytosis is where we have the cytoplasm, and these are the pathogens, and it fully engulfs the pathogen entirely. And this is the white blood cell, and it completely engulfs it, and then it breaks it down with enzymes. And these are the steps where the pseudopodia, yeah, this is why I'm not a pre-med major, surrounds the microbe, and the pathogen is enclosed in a phagosome, and the phagosome it fuses with a lysosome, and then the microbe is destroyed by toxic enzymes, and the debris is removed via exo exocytosis. Okay, next we can talk about the inflammatory response, which is triggered by physical injury or pathogen entry. This is essentially like saying you're mobilizing the immune army, which is kind of corny, but it's okay. We have histamine when it's released by mast cells and causes vasodilation, And then we have increased permeability, and it allows fluid and phagocytes to enter the tissue. And local heat speeds up increases, which speeds up metabolic reaction for repair. And the systemic effect can lead to fever, inhibiting pathogen growth. And then we have the self marker, or the MHC right here. We have two different classes shown below. And then the MHC is the major histocompatibility complex, which are proteins that act as cellular ID badges, which is like a school ID, your driver license. And the class 1 is found on almost all nucleic body cells, but class 2 are only found on professional antigen presenting cells like dendritic cells and B cells. Next, we're going to talk about our humoral immunity. This figure didn't load for some reason, but our B cell activation occurs in the blood and lymph B cells, and they recognize intact antigens. And once they are activated, they are differentiated into plasma cells, which are antibody factories, where antibodies are created, or memory B cells, which are reserved for future infections. Next, let's go into the anatomy of an antibody right here. So we have binding sites right here, which can vary. And then we have constant regions in a light chain and a heavy chain. And these are known as, oh my, immo, immunoglobulins. And these are Y-shaped proteins that do not kill pathogens directly, but they mark them for destruction. And the different regions are variable, which are the unique tips that bind to specific antigens. And then we have the constant region. Oh, don't mind that sound, but which determines the antibody class. Like there's different classes of antibodies. I don't know why that keeps beeping, but I scroll down. Okay, next we have cell-mediated immunity, which is we have helper T cells, and these are like almost the generals, and they secrete cytokines to activate both B cells and cytotoxic T cells, and they recognize antigens on MHC class 2. And then we have cytotoxic T cells, and these are the assassins, and they recognize antigens on the MHC1 class, and they destroy infected body cells using perforin and granzymes. So we have immunological memory, and this is how like the body remembers diseases. And our primary response takes 10 to 17 days for peak antibody production, and the initial lag while B cells are cloned. And the secondary response is at peak production and faster, stronger, and long lasting due to memory cells. As you can see here, when you're it's the time frame of when you're infected, and it shows how long the response takes for each exposure. And then, but okay, now we gotta talk about actually acquiring immunity. And first off, we have active immunity, and that's when the body actively produces its own antibody and memory cells, like catching a cold or using artificial vaccines, where it introduces weakened or dead antigen to create helper T cells and memory cells. But we also have passive immunity, where antibodies are transferred from another source, like mother to fetus via placenta or breast milk. Or we have artificial, or injection of antiserum or ready-made antibodies. Now we have some practice problems. Okay, first up, the I don't know why Jerry put the answer in the question, but a person exposed to a pathogen for the first time, they recover, and 6 months later, they are exposed again. Which is the correct response? Just pretend you don't see the correct answer. Da, da, da. Okay, so I hope you chose C, because it's gonna be faster production during the second exposure. I don't know what this means, but okay, now we're gonna go to the immune response, our summary, and you just gotta remember these things, like that barriers keep things out, or cell mediated means T cells destroy compromised host cells, and distinguishing self from non-self is the key core to our immune system. And Jerry still hasn't fixed the image sources, but here are the sources I used. I hope you learned something, and I'll see you in the next video. Bye bye.